Welcome everybody to this version of we're learning about Geogebra 3D calculator. We are about to take a deep dive into Geogebra 3D calculator. So let me share my screen and we will rock and roll. So let me just minimize that until it goes away. So let's go over here first. So obviously this is what we're talking about right here. This is what you all signed up for. We're gonna, in the next hour, we are going to take baby steps into exploring Geogebra 3D calculator and really see how this app, this powerful app, in my opinion, it's Geogebra's most powerful app that they have, that this app can foster active, engaging learning for students all the way from elementary school, the early grades, all the way up to middle school, high school, and even, university, like multivariable calculus, if you will. Okay, this app has a place in your classroom for sure, because after all, as I've said many times, we live in a 3D world, but yet much of the mathematics that students study, unfortunately, especially in the middle school and in the high school, is really only in the coordinate plane. We're really only in 2 dimensions. And the only time we talk about 3 dimensions is surface area and volume. And the sad part is that it often just simply becomes an application of real algebraic substitution, and there's no really exploration or in-depth kind of study. But we're gonna actually put that aside and say, yes, our students can build in 3D, and they can explore in 3D, and they can discover in 3D. And to do that, we'll go to Geogebra's homepage right here. It's geogebra.org. Okay, www.geogebra.org right there. Okay, and if you're willing to take the next minute or so, I'm going to humbly ask you to sign in. If you do not have if you have a Geogebra account, please take the time to sign in. If you do not have one and are brand new, would you please go up to the upper corner here where it says sign in? You see my picture there, but you'll see a sign in feature. And if you could take a minute to sign in at the moment, that would rock, because the reason why I'm asking this is so that you can save any 3D construction that you make along with me tonight. So take the time to go ahead and sign in if you have an account, or create an account if you don't. And there were some questions asked in the chat here. Let's see. Where are they? There we go. There's people in the UK. We're from, wow. Tracy, you're up in the middle of the night. Welcome. Texas, Minnesota, Worcester, Mass, Dubai. 5 a.m. in Dubai, ladies and gentlemen. Unbelievable. Welcome. Man, got up early for me. I feel honored. This is awesome. So yeah, go ahead and create your Geogebra account, if you would. All right. And if you've done so already, well, actually, now we'll get to that later. All right, so go ahead and create the account. Easiest to do it through Google, which is the way I think most people do it. Takes 2 seconds. Otherwise, you have to wait 30 seconds for a confirmation email, but it doesn't take long. So what we'll do actually is go here. Like, this is Geogebra's main page. Geogebra consists of really 2 components. We have apps and we have resources, right? Now, resources can be found all down here, right? Basically, resources are activities people have made using Geogebra's apps, if you will. Okay, but we have apps over here, a few here. We have a few over here, right? Now, I like to actually direct people to the upper right corner here, the 9 squares, right over here. And we're going to play tonight solely in the 3D calculator. It is by far the most powerful app, and it is my favorite app on the Geogebra platform. And I'm excited to bring you part 1 tonight. And honestly, to be honest, I have no clue how many parts this is going to take. So it could go up to part 8 for all I know, but we'll figure it out as it comes. All right. So go to the 3D calculator, please, and let's explore. Now, I am an educator by heart first, so I always believe that the best way to engage students is to simply at first have them play. And that's what I'm going to ask you to do tonight here. Once you go to Geogebra's 3D calculator, or if you just signed on last minute here, welcome. You could just go look at the URL. It's geogebra.org/3D. I would like you to just Take 2 minutes and play. Many teachers are reluctant to give students unstructured exploration time. And I think that really has to change. We need to give our students opportunities to just play around for 20 minutes. See what you discover. Share with the person next to you. Oh my gosh, I didn't realize, this or whatever. So I'll direct you here. This is the algebra view. This is a calculator. But over here, if you click on the circle triangle, you have some tools. Why don't you go ahead and start playing around with just the basics? You could show more if you want, but I think many of you will be entertained simply if this is your first dabble here. Just play around with some of these tools here for about 2 to 3 minutes. And if you would be willing to drop in the chat anything that you notice or thought was pretty cool or found, whoa, this is pretty nice. Go ahead and play. And if you have any questions, you could throw them in the chat as well. And I should be checking the YouTube thing because I don't know if the chat was enabled there. So let me stop the share here and take a quick peek while you're playing around. I will share my screen in just 1 second. So give me a second here to look for YouTube. Not seeing the chats. Okay, yes, Michael. It's the Zoom that people are on right there. Yeah. So I'm not really watching the YouTube channel, but if other, whoops. Should get the volume. So if other people could actually, if there's some people that are watching the channel for me, if you could do me a favor and say, hey, there was a question on YouTube, throw it in the Zoom chat, that would be cool. I threw the link to the sorry, I can't think right now, I'm so tired. I threw the link to the YouTube live in the Zoom chat. So if you check it out, if you want to follow through on the side, that would be cool as well. So let me get out of here because it's like listen to yourself 20 seconds in the past because there's a little delay. But let's see here. Let me go back and share my screen. There we go, and we'll keep going. All right. So here we are again in the 3D calculator. Hopefully you got a chance to play around. What did you notice? What did you discover? Anything? Anything interesting that you fancy? I mean, well, some people when I work with middle school teachers, sometimes they kind of don't like the z-axis being there because they just want to stick in the coordinate plane. I mean, the reality is, how are you spinning that? If you take your mouse and just go right in the white somewhere and just turn it, you can actually turn the axes and see it, say here from a bird's eye view, right? I mean, the coordinate plane, when you look at the coordinate plane really right there, you're really looking at it with the z-axis sticking out at you, right? The x-axis is red, the y-axis is green, and the z-axis is blue. Just think, RGB, red, green, blue, X, Y, Z, right? If that helps. Now, I labeled my axes because I get confused, but yours probably are not labeled, but you can actually label it. I can show you later, but and save those default settings. But what we could do is if you don't like it, why don't you right click? Let's right click in the white somewhere and just turn off the axes. Just shut them off. Again, right click, you can turn them on. Right click, turn it off. Same thing with the plane. Notice you could show a grid there, right? Quick little shortcuts there. So zoom to fit is like a TI zoom fit, so any objects that you have, GeoGebra will choose a window that will fit everything in there. Okay, it's pretty neat. But let's turn off the I'm going to turn off the grid. I'm going to right click, turn off the axes, and let's just plot some points, right? These are points anywhere. Now, a lot of you know this already, but when you plot points in here, right, notice you see an up and down arrow. So if I press my mouse down, I can actually lift C above the plane, right? Or if you click on the mouse, notice how I have like a north, south, east, west kind of orientation. That allows me to move C now at the same height above the plane. The height of C is not changing, or I should say the Z coordinate of C is not changing, if you will, but the X and Y coordinates are. But if I click on C again just once, I can actually press the mouse and move it back on, or now dip below and see here. I can just, and then go out in the white, I can, whoops, I have point turned on. If you want to move stuff around again, you have to turn, notice here the point tool is still turned on. You have to turn it off by hitting move, right? So I can actually now see how C is now below. And I can go up here, I could bring it like this, right? And so there you have it. So we're working in 3 dimensions now. Now, geometry teachers, I think something is maybe kind of going in your mind a little bit here. Say, hold on a second, wait a minute. I mean, those of you that teach that whole axiomatic method, right, where you have axioms or postulates, right, and then we prove theorems from the postulates. What's one of the first theorems that, or actually, I think it's a postulate, I remember, but Euclid, right? But a plane here, right? You know, through any 3 non-collinear points, there is exactly one plane, right? But we often just tell kids that. But let's actually have them build it. You know, it says plane through 3 points. So I clicked on that tool. I clicked on C, then B, and now I select A. That is the plane. Now again, everybody forgets this. You got to turn that tool off. The plane tool is still turned on. Turn it off by hitting the select arrow. And now, check it out. I can actually take this and drag this. Whoa, now I could try to make them look parallel, but they're probably not, right? But again, what do we want students to kind of just tell us? If students can build this, which they totally could, right? Your role as a teacher is to facilitate that building, if you will. So give them 3 steps. Hey, plot 3 points, make a plane through them, and then let's see where this turquoise plane and this gray plane intersect. Well, if that's the case, I guess which tool up here should I pick to describe where those 2 surfaces intersect? Again, you see it right here, right? Intersect 2 surfaces. This tool is very simple. All you need to do is touch one and touch the other, and boom, there it is. Now let's play with it and move it around. Turn that tool off, right? It's still highlighted. You got to hit that little arrow down there and just play around, right? And now, yes, geometry teachers, I have used the ceiling meeting the wall. Hey, where does the ceiling meet the wall? Oh, at the top edge of the room, right? Or the floor meets the wall, whatever. But you know what? For some reason, it just, I don't know. There's a lot of students that just don't see it for some reason. But if you have students take the 5 to 6 minutes just to build it and play with it in here, I think that if you ask them to describe the intersection of 2 planes, oh, it's a line. I'm pretty sure that they can actually tell you that without you telling them. Again, that's why I love Geogebra's app so much. Yes, they are powerful. And yes, you hit the word more. Oh my goodness, there's thousands of tools. People get anxious, right? But there's no need. We're going to take baby steps here. Okay. We're going to start with the basics tonight, and we're going to go in as many parts as we need to. And we're going to go through anything and everything that this app can do. Okay. So let me just check the questions up here. I thought there was somebody that put something here. Hang on a second. Just check the chat. All right. Hello, Shelly, Audra, and yes, Ardell. After rotation, is there a reset button? Well, after I spin it around, the way I stop it is just to basically click anywhere in the white and it stops. That's what I do. But in terms of resetting, there probably is. Maybe one of this projection. You could choose a projection here. Oh, if you have 3D glasses, you know, somewhere stashed in the closet at home, you could sort of do that. And granted, I shouldn't do that because it's gonna mess with me now. But yeah, let's turn that off. But oh, hang on. Hold on a second. Let's see. No, I just turned it on. Let me just go to something different here. There we go. Orthographic works. But yeah, so there's, again, just one example of something that we could do here. Now, if you want to actually throw coordinates in here now, you're more than welcome to. If we right click anywhere, right click and go to show axes now, right? And you can actually now see, you could touch point C here. If you touch point C, you notice a little style bar pops up. Yeah, you could change the color, you could change the label. Let's show the value. Oh, what is the value of a point? It's the value of a point, obviously, is its coordinates, right? So we could see here, right? Go to AA, we'll show the value. This one's below the X, so I'm guessing Z should be negative, right? And yep, it is. See what I mean? But right here, you can actually move this around and just zoom in, zoom out. You can have a lot of fun with it. Okay, and see. We could what would happen if I gave everybody a Z coordinate of 6? Well, let's see what happens. 4, 5. Whoops. Oh, there we go. And let's move A No, that moves left, right, but let's move A up to 6. I'm watching the Z coordinate right there, right? Look at that intersection. What happens? It goes, oh my gosh, it's going infinitely far away. Oh, yeah. How would you describe that now? So you can ask students to move it and say, oh, okay, well, those planes are parallel. And if you actually scroll back to the algebra view here, right? These are the tools. This is the algebra view. In the algebra view, you'll notice that anytime you create something, GeoGebra gives it an object name right here. And notice it says intersect path of P, and that gray plane there is undefined. And I like to ask students, why is it undefined? Well, because they don't cross. Why? Oh, what does it mean for planes to be parallel? They never meet, right? So yeah, again, just simple exploratory investigations here that you can easily do with your students. They can play. Again, have them play, they tell you. That's my philosophy of education. That's why I use educational technology. I don't use tech just because tech exists. To me, that's stupid. But I use technology to help foster active student learning and engaging learning and fun. All right. So now what you could do here, I'm actually going to take all this. If you click the snowman here, I'm going to delete it. Right? Delete. You could hit the refresh button, but I'm too lazy. So we can get rid of everything. Let's actually go plot a cube now. Some of you are going to really fall in love with this app after we do this. But let's go touch the cube tool. All right. And notice anytime you click on a tool, it tells you what to do. Select 2 points. What does that mean? Let's plot them. Let's plot a point at the origin right there. Again, cube is turned on. Let's plot a point over here. And let's plot one over here. And then like students kind of like, huh. And I asked students, well, why'd you go, huh? What do you mean? Well, you would think I'd have to plot more points to make a cube, don't you? And then I'll look at the class and be like, well, that's a good question. Why talk among yourselves for a minute? Why is it that we only need 2 points to plot a cube? Why? You know? And they think about it. Well, gosh, what does it mean for a polyhedron to be a cube, right? And that, oh gosh, yeah, all sides are squares, every edge is identical. So therefore, and we know, and the class has a discussion with that. Again, I'm going to turn the tool off by hitting that arrow down there. That arrow, whenever you turn the tool on, that arrow always shows up by default. So get in the habit of clicking it after you do something. Now, when I plotted these points here, B was like on the, notice how B is glued to the y-axis, right? You see there? Kind of look right there now. I can see the cube from here, from there. Oh, and shall we, you want to talk nets? Many of you elementary and middle school teachers, we talk nets, right? The net tool is right here. Click on it and just touch the cube. Boom. And watch, it gets even better than this, because now if you turn that tool off, again, how do you turn that net tool off? You got to go back and select the move arrow or the blue arrow that's way down there. All right, you made the net. You can notice that there's gray points here, those vertices. You could pick up any one of those and fold it back up. And I wish I could hear the oohs and ahs, going on right now, but it's pretty cool, right? That you can see. And again, I love showing this app off. It's pretty cool, but who knows, when it's all about perspective, if you look at the edit tools right here, if you click on the eye view in front of, right, check this out. If you view in front of, I can view it directly from this angle, click. I can view it directly from, want to look at it just this way. GeoGebra will adjust the perspective, if that makes sense. So you could see it literally from any angle that you want. It's awesome. Totally awesome. Okay. So, and again, we're just barely getting started here. Now, yeah. So again, let me turn that tool off. And again, I could adjust this all I want. Now you can show stuff and hide things. There's many apps that have those bubbles on the side. I can hide the cube, see? I had the cube right there. And I know EFG and H are there. I'll show you how to make them go away later. But right here and right now, or I could actually just click on F for now. Go here to the snowman there, go to settings, and I can uncheck show object, right? Touch E, you can uncheck show object if those 4 points up and hovering up in space are really bothering you. You can do that. All right. And yeah, you now have a net of a cube that you can play around with, do what you want. So in terms of discovery learning, the simplest of simple things, you just have the students walk in and say, hey, I have a cubicle room and a cube room. I want to paint the walls, it's X dollars per cubic foot. You know what I'm saying, right? How much is it going to cost to paint? But I don't tell the students, I never write on the board 6s squared. I have them build there quickly and they tell me. And there's been some times I haven't built it out of paper. Like, how would you make a cube out of paper? The paper should not go away. Again, technology does not make a lesson better. It's what we do with it that makes it better, of course, right? It's how we use it, all right? But like literally right here, when teachers are like, oh, should I just give them the form? We got to review surface area and volume. We have to review because we have to be in the curriculum, say we should be like 8 miles ahead, but now we're not, you know? Well, if that's the case, I propose don't give them any formulas, have them build here quickly and then make the net, and they can come to discover, oh, right, area of a square times 6, duh. You see what I'm saying? It's just a whole different way of then the students are driving, you are helping the students drive their own learning. That's what GeoGebra helps you to do very well and very effectively. Okay. So yeah. Yes, net for the pyramid, we could do that after too. See the bottom. So I can pull up the bottom of the screen a tiny bit. Maybe I see the bottom. Let me see here. I could try to go with, does this help? Maybe. I don't know, because I always thought full screening. I guess people are saying we don't like to see tabs, but let's see if this is better. If you can comment, that'd be cool. But yeah, so we can make the cube, we can play with it and do whatever we want. But now let's actually talk about life is circular, isn't it? In a way, let's actually make a sphere. I'm gonna delete the cube and let's just play with spheres. Again, these are the basics. Just gonna delete, 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 here and here. And I'm actually going to hide everything. So let's just right click and just uncheck axes. I want just to work in free space. Okay. So now let's make a sphere. Here we go. And I'll turn it off. There's my sphere, right? And now let's actually, here's a little more advanced geometry investigation that I could ask students to do. I asked my geometry kids to do this. And I would say that 7th and 8th grade students could totally do what I'm about to show you here, as well as 10th grade, okay? But right here, I want to make a plane through 3 points now, which you know how to do. So here's what I want you to do, and I want you to build this with me, okay? Let's actually make a sphere. Again, just click a point, that determines the radius, right? And now let's make a plane through 3 points. So just click, and we'll move it up maybe. We'll click and we'll go down. I just don't want it to coincide on the grade plane, that's all, because points naturally start in the grade plane when z equals 0. And so click, and I'll move it up just a little bit. See what I mean? So I have a plane, and now I have a sphere. Okay, so what we're gonna do now, again, I have to turn everything off, hit the select arrow down there. Oh, what did I just do? Undo. Oh, by the way, I don't know what I did, but I undid what I did. I love the undo button. Control Z in GeoGebra is that little icon right there. All right. So now let's go hit the move arrow there. And there it is. Now notice that this plane is slicing through the sphere. So, but I want to hide the gray plane. So let's actually right click somewhere anywhere in the white and uncheck show gray plane. I just want to look at the turquoise and the red. Now, if you're like me, that red might irritate you a little bit because I don't know, the colors kind of clash too much. So if you go here, we could adjust the opacity. See what I mean? It's pretty sick, quick and easy. It's nice. Or you could hit the plus sign. You could choose from a palette of colors. And for the artists in the room where RGB, red, green, blue is very important to you, a little sneak peek here. If you go to advanced, you can actually type in coordinate. You could type in numbers, red, green, and blue, and it'll turn the sphere that color. Like all red would be 1, 0, 0, right? And all green would be 0, 1, 0, right here, here, here. But interestingly enough, GeoGebra is used, shoot, I don't know what happened there, but whatever, but I could change it. Settings, but when it comes to accessibility and for publishers, like GeoGebra has a lot of partners that that use, you know, GeoGebra software embedded, the apps embedded within their API. But when it comes to accessibility, red and green don't go well together because there are students with color blindness issues. So it's a good, you know, playing with colors, even though it is actually discriminatory to identify solids by color for students. Where does the orange sphere meet the green sphere? You can't do that anymore because that's unfair to those students, you know? But let me make it pink. All right, I think that's a nice kind of, that's a much better approach there. So let's see. So let's do this now. Katie, to answer your question, the best way to get students on GeoGebra to actually build, if you're in an iPad district, I would strongly recommend downloading the app from App Store and not using it in Safari. Right now to answer your question, Katie, right now on iPad, it's not possible to save a construction on iPad and have it upload to your GeoGebra account. If that's the case, you're gonna have to build it in Safari, but GeoGebra is working on that. It's just not, that functionality isn't there yet. It's there for Android and like the Acer Google Chrome tablets, things like that, but it's coming, it'll be coming for iPad. I just don't know when. All right. But yeah, so, yeah, so right here, I can actually see here, I want to see where this plane and sphere cross. So let's actually use the tool we know. Let's plot their intersection here in the sphere. And then I'll turn it off. And now at this point, I like to role play and say, okay, when I work with teachers in districts, I have teachers build this. I say, okay, I want you to play the role of student now. Look at that intersection for me. Heck with it. You can go over here. You can go to the algebra view, right? And you can actually turn things on and off. Turn off the sphere, turn off the plane. Just look at it head on. And everybody says, gosh, that looks like a what? Yeah, you're thinking it looks like a circle, doesn't it? But again, can't go by looks. I want you to work with the person next to you, and I want you to actually play with GeoGebra's tools here, right? And convince me it's a circle. And that is, oh my gosh, you're putting students' brains together. They're collaborating, higher level thinking. These kids are playing with these tools like you would not believe. All right. Again, my students naturally wanted to play with the tools because I think, again, it's not rocket science, but again, you start the year, at the beginning of the year, you start by having kids play for 2 or 3 days straight. See what you can build, see what you can make. How'd you do it? They become masters of the tools. And then when you're in the curriculum, say 3 or 4 weeks from now, like when I started teaching, I was often like maybe like the first 2 months, I was always behind. Tim, you got to catch up. Tim, you got to catch up. Like, you know what? No, I don't. My students are fine. You let them be, But the thing is, by December, January, I was like it was like 2 or 3 weeks ahead of everybody, and I have to slow down because the students are the ones building, right? Remember teachers, and I know you know this, but it's like teaching and learning has absolutely nothing to do with what we cover. To quote the words of Henry Wong, First Days of School. Teaching and learning have zero to do with what you cover as a teacher, but it has everything to do with what the student accomplishes. And focusing on what students are accomplishing, this app right here, I mean, for crying out loud, we live in a 3D world. Why aren't we building more in 3D in our curricula? I have no idea why, but we need to be. You could start fostering that change in your classroom with this app. All right. So now this is kind of pretty hard to construct with paper, right? I mean, for you people that study higher mathematics, topology, right? It is virtually impossible. It is literally impossible to create a sphere out of a plain 8.5 by 11 piece of paper. You can't do it without crinkling it. You can make a cylinder, like you fold it over. You know what I mean? A cylinder you can make by turning paper around, but you can't make a sphere. So the paper models go out the window. Here we need an app for kids to mess around with and play and build. Okay, so how do we convince ourselves? So I'm going to try to save time here, but let me actually go here and hide this again. I'll give you a hint. We'll hide it. Whoops. Hide. Well, I don't want to hide. I want to hide the plane. I want to hide the sphere, but I want to show the intersection. All right. Gosh, that looks like a circle, doesn't it? But how do I have my students prove it to me, or convince me that it is? Well, we're going to learn how to mess around with a few more tools here. And I'll give students hints here and there if they really looking forward to it. But some kids have figured it out, which is you'd be pretty impressed what they do. But look at this. I'll give you a hint here. There's a point on object tool here, right there. Let's click on it. We could put a point on that intersection, on that circle right there. There you go. I'll undo it in case I did it too fast. Point on object is highlighted. I just touched like the edge of the circumference of the circle there. Boom, F, or the circle itself. Again, I'll turn the tool off. And what else does every circle have to have? What is the most important point of a circle? Feel free to type it in the chat too. Given a circle, what is the most important part of the circle? What would you say? Type it in. Yes, Shelly, Katie, the center. So guess what? GeoGebra has a center tool there. Very good. Awesome. So look at this, right? So right here, we can actually go, and there is a center tool down here somewhere. Yes, I get lost in the tools too. It happens to me. So don't feel bad. Here it is, under points, midpoint or center. And all you have to do is click on the circle. Aha. And there's, they call it G is the center there, right? So, all right, teachers, help me out now. Type in the chat. I'm watching the chat like a hawk here now. Convince me it's a circle. What should I do? How could I mean, I can move F around the circle all I want, but how convince me, I'm sorry, I'm assuming it's a circle, but how do I know it's a circle? And this is like a discussion I have with my student, measure radii. But the thing is, Archo, how do I know it's a radius even? Because the radius has to, oh, thank you. Yes, Shelly, measure distance from G to F. So I can do that. There is a distance tool here, somewhere down here, somewhere, distance or length, right? It's under measure. I could touch G, I could touch F, and it says GF is 5 6/100. Or another thing I could do, this, again, it makes a text box. To me, it kind of looks ugly, but that's one way. And look at this. Ooh, nice. Look at that. Very good, Shelly. Another option I could do is make the segment. If I go up to lines and polygons here, I'll make the segment there. Connect G to F, right? I mean, is that a radius? By using the center, you need, actually, Martin, I don't think so, because aren't there other conic sections that are not circles that also have a center? Like I'm thinking of an ellipse or even a hyperbola. I mean, we know like a circle is a special case of an ellipse, right? With zero eccentricity. But right here, if I go, let me turn that tool off. If I click on the segment there, and then I just show the value, and now I could turn this around. Actually, I'm going to delete that text box there. I don't like it, right? But now I turn that around. Look at it right there. Okay. So now, again, is this a formal proof? No, but who cares? This is an informal proof. But oh my gosh, if your students can work together for like a period and use deductive reasoning to kind of, with this kind of logic to build this and to analyze, then your students are now becoming that much better critical thinkers, in my opinion. All right. And that's the kind of pedagogy, I love to see. And that's what you really want to foster. Now we could turn everything back on. Let me turn that sphere's opacity down a little bit because it's a little too dark for me. All right, right there. And maybe the plane a little bit too. Yeah. So you see it there, kind of see it on my screen. But now look at this. I could change the radius around. Holy moly, look at this. And I could look at that. Now it's 5 19/100. Let's move the plane. Is that radius always, is that distance always the same? And this doesn't, doesn't this motivate the definition of a circle? A set of all points in a plane. Students always forget that in a plane part. It's a set of all points in a plane that are equidistant from another point that we call the center. That's literally the locus definition of a circle there. But see, I mean, and all we're doing is playing around, we're building. Now, granted, this is not, we're not here to analyze the standard form of the equation of the sphere in 3 space, even though GeoGebra names every object a name, a descriptor, and it has a value. The value of the sphere is its like equation, but you know what? Who cares? Students don't need that. So ignore it. But see here, now you have what you have here. And if you ever wanted to throw coordinates on that, right click and then show your axes and then throw your plane back in there. And man, now you can, you calculus 3 teachers can go wild. Okay. See, we're addressing a lot of the curriculum here. We're talking about cross section in middle school geometry, high school geometry, but now by slapping coordinates on these points, we're now doing really equation of a sphere, which we could also do in a geometry or pre-calculus course or algebra 2, totally, right? But again, a textbook, again, the book is not the Bible of a course. So I want to make that clear. Your textbook is not the Bible. A book is not a curriculum. A book is a supplement to a curriculum, right? But you as a teacher, learning mathematics is a journey, not a destination. And Geogebra 3D Calculator makes that journey so much more fun. All right. So let me show you quickly how to save your construction. All right. So you might want to go back to this tomorrow and build on it. Okay. So in order to do that, I'm going to leave it the way I want to save it. You have to make sure you're signed in, which we are right here. Okay. And we'll go right here to the main menu. It's the hamburger menu right here. And we'll just go to save. And I'll call it, say, sphere and plane intersection, whatever. Right? Now with visibility, there's 3 types. Well, right now there's actually 3 types. There's public, shared with link, and private. If you make it, it defaults to shared with link, which is really the equivalent of an unlisted YouTube video. Okay. On YouTube, I think it defaults to public when you try to upload a video and you have to change it yourself, or maybe you click a checkbox. I don't remember, but point is, nobody. So if I save it, nobody in the world can find this construction. It's just mine. But if I give you the URL, which I'll do now, see share is right here. Right? I could share it with you, or I could hit the share. There's another share icon right up here. You could take that and you could take that and just copy it. You could print it. You can export the image. Oh, by the way, .stl 3D printer people, you know what? Let me just copy that and I'll throw it in the chat there just so you can see for yourself. That's how you can quickly share your constructions. Maybe you're a teacher that wants to assign something like this in Google Classroom, or maybe Schoology or Canvas. Honestly, I really don't care what your LMS is. That does not matter to me. What matters to me is your students building. And then they take what they have here, they take that URL and they could drop it. In this case, I'll drop it right in the chat. And there you go. Well, did I just send it to everybody? Or I think I just sent it, not to everybody, but just hang on. Just one person. Oops, there it is. So if you open that thing in the chat there, you can do that. Well, Martin, you could. I mean, to answer your question, you could, but I just know that, I mean, GeoGebra is powerful. Again, I have no clue how they built it, but I know that you don't have to assume it's a circle if it has a center, because yeah, we mentioned that already. There's other conics have a center, but yeah. But if you want to stick around after 10 o'clock, I'll stick around a few minutes after I stop the recording. If you want to unmute your mic, we could talk about it because I'm kind of curious. Shelly asked, can I get an embed code? Yes, I can. Shelly, it's right here. Let me see here. I was actually going to go through that after. But actually, I'm going to make a note of that. I will do that. Actually, no, let me do it right now. So to find your construction here, right, I'm going to go to New tab, go back to GeoGebra. All right, right here. And I go to my profile. This is the home page, but all of your stuff is stored in your profile right here. And if you're not logged in, you click profile, it's going to make you log in, whether you like it or not. So you go to your profile and you see how the latest thing is right there. That's the latest thing that I did. Now, if you click, now here's the thing that confuses a lot of teachers. If you click on it, this is kind of analogous to looking at a Google Doc that you have view only access to. Notice I cannot edit it. You know, notice how the tools in the algebra bar up there, all I can do is I can play with it a little bit. Oh, Tim, I just messed up your construction. No, you didn't, because all I have to do is refresh the URL and there it is again. You know what I mean? But if you want to embed it, I would highly recommend first. I didn't intend to do this part tonight, but I'll do it because you asked. But really quickly, if you go here to this hamburger menu, if you go to edit activity, GeoGebra actually makes an activity, believe it or not, every single time that you save a construction. It's just that there's no questions or words around it. There's no anything. But if you see how this is, if you click on this little pencil here to edit, I don't know why GeoGebra defaults to this, but because really most teachers, Shelly, want to just share the graph, the construction, just so I can open it and see it. But if you want to embed this thing in some kind of on a platform, I would recommend first making the width maybe like 900 by 500. Because for small Chromebook screens, that thing is going to be a beast to load. It's going to be a pain in the butt, and you don't want that right there. Okay. And so now I can kind of zoom out a little bit there. Okay. Yeah. And so I can kind of show that right there, if you will, sort of thing, move it aside. See how it's much smaller now? And now anything that I had the power to do, I like to give the students the power to do whenever I have them work in smaller windows like that. Again, this is more of a resources tutorial than the 3D, but I'm happy to answer this. So again, anything I like to give the kids the power to do, I give them the power to do. So now, Shelly, when you embed this on Schoology or Canvas or wherever the heck you embed it, you can do that, hit done, hit save and close, right? And now So now this view only is now like kind of editable, if you will. If a student goes here, they can go back, they can make a new copy and save it. But in order to embed it, what you do is go to details. All right, to embed any 3D construction you make in any platform you have, click on the three dots, go to details, and it's actually under share right here. Share, you get the hit embed, select all, copy it, and that's what you paste right there. So let me just go to Schoology to quickly demonstrate. I think I have a sample class right here. Log in. Yep. And then let's just go to the sample GeoGebra course. Let's see how it looks. So I'll just quickly add the materials. Oh, my bad. Courses, sample course, unit 1, embedding GeoGebra content. So I'll basically add a link right here, embed it, and then boom. And then look at that, opens up right there, and I could play with it just like that. Okay. But let's get back to there. Let's get back to the 3D calculator though. All right, let's see. Yes, you can also share. Absolutely, you're very welcome. Okay, so now back to the 3D calculator here. Other tools here. So let's just totally. Oh, by the way, one other thing with respect to saving. Remember, this was my first file. Let's suppose I put something else in here, I'm going to mess it up just a little bit. Let me just make another sphere and another sphere. Let's suppose the teacher gives me a construction in stages, right? So maybe I want to make a molecule for chemistry. I've seen like water molecules made perfectly to scale here. This is not just for mathematics, by the way. So right here, I can go here to save again. Now, just like I hate saying Microsoft Word, so feel like it's old school, but we all love our Word for some reason, right? But I love Google way better. But that doesn't matter. Point being, for this right here, if I give it a different name, that's like a save as. Okay. If I call it the same name and hit save, GeoGebra will override my old file with the updated file. But if I call it something different, just like Word people know, hey, it's save as, I hit save, it's going to create, watch the URL changes. See the URL just changed up here? It makes you a brand new link. So now when I go back to GeoGebra, I go back to my profile, and literally, if I go right here now to the dots, if I hit open in app, not edit activity, I just want to open it in the app. Right there, that URL is what I can give my teacher in Google Classroom or whatever the heck you're using, right? And then that's it in terms of sharing. Sharing is very easy, very easy. All right, so with that, let's look at some other tools. I wanted to actually touch a little bit on augmented reality tonight, but I think I'm going to save that for next time because we're just getting started. I'll do a 5-minute teaser for the next session, with 5 minutes to spare. But right here, let's go back to 3D. And let's look at some other stuff students take a look at. Okay, let's see, close that out. But right here, we learned a lot of these tools already. We built with this. So obviously, people are kind of interested in this next, really, right? Like, how do I make pyramids, prisms, tetrahedrons, right? We know how to make a cube. That's obvious. Sphere. This one is a sphere with center and radius. So maybe you're working with a sphere and it's a fixed radius. So just click on the tool and notice when you click on a tool, GeoGebra tells you what to do. Touch it again. Select the sphere center point and then just type the radius in. Okay, well, I'll put it at the origin and I'll say 0, 0, 0. Oh, I'm sorry, the radius. Let's make a radius of 5. There it is. Right, so obviously I can, that's kind of fixed there because I made the radius 5. But if I could put a point here, make the radius 5 and move it, you just move the center, if you will. So that's that tool there. But now, many teachers have wondered, in terms of if you take a look here, right, this is kind of where, maybe go to text, but let's do these first. If you want to build, for example, if you want students to work with a tetrahedron, right, just plot 2 points. And you have, because the tetrahedron, remember, is a platonic solid, right? So every face is an equilateral triangle. I mean, that thing. But a little shortcut here. This is a little GeoGebra hack. I mean, you see, these are tools. It's not really a hack, but these are actually tools. But behind every tool is a command. Now, GeoGebra has hundreds of commands in this app, And honestly, I probably know only about 15 or 20 of them, to be honest with you, maybe a little more. I don't know that many commands, but when I don't know something, what do? You Google it, right? So right here, if you actually plot 2 points, watch this, 1, 2, you can actually make an octahedron. Just type it in, octahedron, and notice there's 3 ways to do it. I'm an octahedron here, point, or point, direction, whatever, but let me see, might need another point here. Yeah, let's try that, see what works. Octahedron, say G, F, G, P. Actually, no, actually FG is will do, because yeah, I'm not sure why the 3rd point was there, but the point is, no pun intended, right? Really, that EF is kind of like the edge of one of the equilateral triangles, since it's already pre-built. I can move it up, I can analyze it, I can make the net of this thing. Sure, I could. Look, don't believe me? Let's do it. Let's make its net touch. There it is. What? Yeah. We turn it off and we could fold it. Now we're really getting messy. Let me refresh. Sorry. When I get excited, sometimes I go too fast. But right here, again, let me turn off the axes there, clean it up a little bit. And let's let's plot 2 points. 1, 2. We made an octahedron, but we could also make what's one of the other platonic solids? An dodecahedron. Dodecahedron, A, B. There it is. Holy moly. Yeah, look at that thing. It's like, now every edge is labeled there. Now, I know that the label is ugly. I could show you how to turn it off really easily. By the way, you could send this to a 3D printer if you really wanted to. Go here and go to, you export it right over, where is it? Download as, and you see you people that are used to 3D printing, you see what you need here. I guess TL or something, but you could totally do that, totally. Okay, now now people here are asking me, how do I get rid of those? Radius with a slider is not possible in 3D. No, Audrey, thank you, Audrey. I really appreciate it. You can put sliders in here. You just can't put sliders out here in the white. But if I type in R equals 1, right? And let me just make it go from, say, 0 to 5, incrementing by, say, nice and smooth. I can actually go ahead here and use the sphere with center and radius tool. Just touch and then enter the radius R. R is my slider, right? Right there. So you can have sliders in the 3D calculator, but the sliders don't appear out here. You just have to have it in the algebra view. Okay, answer that question there. So these are actually called auxiliary objects. Notice there are like, not thousands, but there are like, what, 32 edges, or I forgot the numbers, but there's a lot of edges here. There's a lot of faces. But notice I don't see all that stuff. See, GeoGebra actually hides it because they know that you're probably not interested in it and you don't really need it to look at it really. But just in case you wanted to, let me get rid of that in this here. Just in case you wanted to, if you wanted to show all the objects, you actually click on your settings icon right over here. We'll go to settings, and now we'll go to where is it? Go to this little icon here, the one that looks like a cubic. And you want to show auxiliary objects. If you check that box, then everything here, come on, come back. I'm stuck in the, sorry, let me refresh. Not bad. Every once in a while I zoom in, it gets stuck. That's a Mac thing, not a GeoGebra thing. But right here, let me just plot 2 points quickly. A, B, get it right back. And I'll do dodecahedron. A, B. There it is. Now they're labeled. So I go here, I'm going to show auxiliary objects, just like I showed you. Now, notice here that this is like, again, there are tons of objects here, right? Anytime something you see something, there's always something behind the scenes, and this is what they are. That's how they're named. So what we need to do, what I like to do, first of all, is go to the sort by. This is very powerful. Right now, GeoGebra defaults to sort by the algebra steps, the view you see on the left side, by the order in which you construct everything. But if you want to, I think it's more useful sometimes to just classify them all by type. So not in order really, but just by type. So check this out. I can now go here, right? See all these edges or segments? If I click on the word segment itself, there, and scroll down again, just click on the word segment. They're all highlighted. I right click in that region, go to settings, and I'll turn that label off. Right? See it all went away, just like that. And so then, yeah, I can actually kind of make, I can hide points, I could do whatever, but the point is, there's my dodecahedron. I could do whatever mathematically say I want to do with it. Okay, but now I want to actually just switch gears here. I want to talk more with constructions. I'll also show you something else here, because right here I brought along, let me just refresh the last 10 minutes here. We can start talking now about, let me just get my iPad up here. There we go. Turn the camera on. There we go. Now we can start building the world around us, right? Spatial reasoning is a skill that is so badly needed with this generation today. We like the spatial skills. Again, part of it is the curriculum's fault. Like we follow the curriculum, we follow the book, but yet there's no 3D. Again, the book is not a curriculum. If we live in a 3D world, our students should be working in 3D. I don't want to keep repeating myself, but here I have let's start by, students can come in your geometry class, whether they're in 5th, they can build this in 4th grade, literally, or they can build it in 10th. I don't care. But somewhere in the curriculum, they need to be building this. Think of how would you actually build this rectangular prism right here? That's 9 7/10 by 19 65/100 by 4 1/10. Forgot to turn off notifications there. 4 1/10 there. How could we build this? How could we build this in the 3D calculator here? Let me actually get that back up and running here. Where is it? There it is. Okay. Let's actually build this. Oh, you know what I found out was really cool? If you take the window like this and just squish it just enough, look at that, look at that. You can make it look like the app on your phone. Isn't that cool? I love that. Again, I was just to show you here, like the Geogebra 3D calculator app, download the iPhone. In this case, looks like this, right? By the way, little sneak peek to what we're going to do next week. I don't know if it's next week or next time. I will tweet it as soon as I know. But right here, that actually is this glass right over here. We talk about, whoops, wrong one. Nope. Hang on a second. There we go. This glass right in front of me. We can build, our students can easily build this. Now, there's a lot of ways we could build this. We can make it as hard as a calculus 3 concept, or we can make it as simple as a 6th grade. Oh, make a cross section and spin it around concept. And that we're going to actually do next time, because watch this. If we go into the 3D calculator right here, right? All I did is plot 2 points and I made a segment, which we could do in the computer right here. In fact, next week, we're going to actually, I built this solely on the iPad here, but we could actually build in the computer. And actually, because I like to build on a computer or Chromebook and then save it and open it on an iPad. I find that to be easier. But for you that are in iPad districts or tablet districts, then you don't have that option, right? So you could actually build this on the iPad quite easily. But right here, you actually simply, whoops, hang on. There, you can actually talk about, a cross section right there. That's very easy to do. Your 4th and 5th graders can build that literally. So we talk about modeling the world. We talk about modeling the world around us, right? And that little button AR is called Augmented Reality. And if you own an iPhone or an Android or some kind of smartphone, you actually have it already. Just don't realize it. But look at that. You can actually gone are the days of 3D goggles. You don't need them anymore. All right, those clunky goggles there. But look at this. You take it. Next time we're going to start doing more of this. Having students build this. Can you imagine? Like, oops, hang on. Let's fit that better, but look at this here. You take that glass. Augmented reality, yeah, it's a great visualization tool too, but there are teachers who are critics in the room that say, Tim, why can't I just do it on a computer screen? What what pedagogical advantage does augmented reality bring to the table? And I tell teachers, the one thing that I can think of is that it allows students to virtually test the accuracy of the 3D models that they build. Look at that. Now, I'm walking away from that thing, you know, but if my students in my middle school geometry class can record me a screencast, upload it to YouTube, and then they send me this, you know what? I know that I'm not worried when the paper and pencil test comes and there's a question about cross-section. I'm not worried about that, because if students can build it, they know it. I'll say that again. If your students can build it, then I would say that most of them can recall it on some kind of standardized test or whatever. But then we could even, next week, we could even switch gears and say, look, oh my gosh, what if I had this? Now, can I author a function? Look at the point. There is no algebra teacher or pre-algebra teacher in this room right now. Let me turn this off right here. Oops, sorry, hang on. There is no algebra teacher in the room that could tell me, you know, you would expect your students to be able to plot that point and that point right there. That's the y-axis, that's the x-axis. And I think that algebra teachers, you would expect your students to know how to write the equation of that line, do you not? Of course you would. But then by writing that equation, restricting the domain 0 to 14.5, right? That will spin that, and we'll be able to make that same glass sideways. Point being, there's many ways to build many things in GeoGebra. And you know, we're just barely starting to scratch the surface here. So that, more of that, and more prisms and more 3D polyhedra is going to be coming in part 2 of this webinar series, which probably going to do in a couple of weeks, probably 2 weeks, but because I have some upcoming ones coming up first right here. Also want to throw in just a shout out to my friend and colleague Alice Keeler, who I believe is watching. But she and I are going to be hosting a webinar Friday at 11 a.m. Pacific time, 2 p.m. Eastern, with respect to just basically getting started with using GeoGebra. Yeah, today we were in the 3D calculator, but right here we are going to simply build. Right, let me just give you I'll drop the link for it. I can't find it. Oh, Alice could drop it in the chat. She'll drop a chat for you, but we'll keep it there. But again, GeoGebra 3D Calculator, it's an awesome app. You could download it from Google Play or Play Store or App Store. In the chat here, what I will do is drop you a link. If you open this on your phone, there's links to the app stores right away, so you don't have to go looking for it. Just give me 1 second. I will get it to you right now. This is it right here, but there we go. Make sure, again, when you're using Zoom, make sure you select everyone in the thing. There you go. That URL will take you right to this Google Slides thing that I'm showing you right now. The link, open this on your phone. Actually, I shouldn't say that. Open this on your phone here. That's too long to type in. This is what you want to type in on your phone. I apologize. This tiny URL will take you right. If you type this in on your phone, right here, that will just open up your favorite browser on your phone. That tiny URL will take you to that Google Slides link, and you'll be able to get the links to the 3D apps quickly on Play Store and Google Play and App Store. Okay, and if you one other comment, with augmented reality being used as a way to test the accuracy of 3D models we build, if you are an Android user, okay, you need to actually download 2 apps. So I'll keep this up here for another second here. If you have an Android, you actually have to download 2 apps. The first app, the links are right there. If you have an iPhone or an iPad, Apple has what they call their AR kit built right within iPhones and iPads. You're all set. If you have an Android or like a Samsung tablet, whatever, then you have to download the 3D calculator and another app called Google Play Services for AR. Okay, it's free if you have the device, of course, and yeah, upload it. And so if you can get that up for next time, as soon as I know the next date, I will tweet it out, put it on Facebook, whatever. Social media links, if you're interested in more ideas for teaching and learning, take a picture of that barcode down there with your phone, and you'll have access to a lot more resources for you. So yeah, it's about 9:59 right now. So I will basically stop the sharing there, stop the YouTube feed. And If you have questions for 5-10 minutes, feel free to stick around and you can unmute your mics. So I'm Tim Brzezinski. Thanks for watching, and we'll see you right here next time.